the under 50. So I'm creating an array of people that are under 50, filtering it from this array of ages. So as we said, we call a method. If it's on an object, it's called a method, but essentially filter is a function in this case. And what it takes in is a callback function. What we said a callback function is simply a function that is defined as an argument to the invocation of a function. So I am invoking the filter function here, or I'm calling the filter function, but the argument I'm going to put in here is a function definition. So I was using the arrow method, the arrow function definition, which is like that, a bracket, then equals, and angle bracket, then the curly braces. But I'm going to use a different method just to show you that this can actually, you can define a function here using just the other method. The only thing you can't do here is define a method that has a name. So in this case, I would use the other method where you just write the function keyword, and then you put the brackets, and then the curly brackets. So now this is a callback function. I'm defining a function as an argument to the calling of another function, to the invocation of another function. So inside here, I'm going to put placeholder. Let me call it a holder. This is the syntax of the callback function that you're defining as an argument to the filter function. It takes in one parameter, and what that parameter does, let me demonstrate it again here with a simple tool. So if we have an array of numbers in all these different positions, see that we have a number here, we have a number there, there, and there. When we call the filter function on this array, in the function it defines the callback function that is defined inside these brackets. This function now, the callback function that is defined in here, takes in one argument, only one argument. So what this argument represents is that on every instance of on every instance of iteration over this array, for every value, it's replaced by the value here. What that means is that this A, when this filter function is starting to operate, and it has defined this function, the callback function, the A, which is the excuse me, the A, which is the parameter to the callback function, is replaced by the first element in this position. So that becomes the A in the first instance. What is that function supposed to do? I said I'm looking for people that are under the age of 50. So this A becomes the number in that position. And then the operations that are defined inside this callback function are done on that A. Yes, please. Please, I don't think I'm getting this clearly. Any repeat? By that you mean? Okay, I'll go over it again. So we're defining how the filter function operates, the filter method. So we have an array of numbers. Is this okay if I start at this point, or do I have to go back to the code? Okay, so we have numbers here. This is an array. Each of these numbers has a different index. Now, if we want to go to, what we're going to do is, with the filter function, we're going to check if each of these numbers, each of them one by one, when this has been checked, the checker goes on to the second element, and then goes on to the third, and then goes on to the fourth, and then goes on to the fifth, until the array is complete. So if it checks the first element, and it meets the criteria that we want it to meet, out if it was maybe 78, and if this is an age above, rather, sorry, under 50, if this was about 12 years, I'll take it into my new array, the filtered array. So if this meets the criteria, it goes into my array. Then if the second element doesn't meet the criteria, perhaps if it's above 50, it's skipped and the third element is checked again. If it also doesn't meet the criteria of the number here being below 50, maybe it's 95, the checker goes on to the third element. And if this meets the criteria and it's maybe 12 or maybe 20, then it's taken into the sorted, into the filtered array. So I now have two elements in my array, the first and the fourth. Then it goes to the last. If it also meets the criteria, perhaps it's 35, because that is of course under 50. Because my criteria, the criteria that I'm using in this illustration, is simple, is a number that is below 50, as referenced from this array. So if this is maybe 45, it will also come into the array. And now I have three elements in my new array. But how do I design? Yes, please. Okay, that question was directed to Vian. You should probably say something about it maybe before we continue. Okay. Vian, yeah, you can respond to her maybe in the Telegram group. Vian, you're saying you started on the array. So can we continue from where we are so far? Got it. So we have sorted our array according to a criteria that we're going to define, whose syntax we're going to define. Now you can only do this kind of operation on an array through a method called the filter method. I'm using a mouse touchpad method to type this, so it's going to be imperfect. Now, this is a method on the array default. Because of the class from which it's designed, an array is an object. We're going to look at objects a little later. And all objects, particularly those that are designed with those that are designed to be arrays, they all have the filter method. And what it does, it sorts those arrays according to a criteria that is user defined. And this is what it does. When you call the method, the filter method, it takes in a function definition. So the function definition is this kind. We have where the argument will go. Maybe the argument is A. And then for it to be a function, if I'm using this arrow method syntax, arrow function syntax, these are perhaps curly braces. The condition under which this array should be sorted, should be filtered, is going to be put in your curly braces. So this is how the logic goes. I'm going to put the word condition, perhaps. Condition. It's in this curly braces where you put the condition under which your array should be sorted. But for the array to be sorted, each of these elements has to be checked one by one. And that means it has some form of a checking system. And that checking system is this function that has been defined. The callback function, which has been defined as an argument to the filter method. Are we clear up to this point? Okay, I think we should be. Some feedback, please. Maria, Ronnie, thank you. Okay. So the filter function on this array takes in an argument, one argument only, which is a function. Now this function is where you put the condition under which you're going to filter the array. But for the array to be filtered, it has to, the argument you've set in, or the checking method that you've set in, this is like the checking algorithm, this whole thing. This is a checking algorithm that is going to be used by the filter function. So the filter function only enables the functionality of creating a new array based on the condition of the of the filtering system. So the condition for filtering the array is put in that algorithm in the curly braces, just like a function would do operation. So the operation of this function that you've defined as an argument is to sort the array, and the condition is put in the curly braces. But each of these elements, one by one, has to be represented by a placeholder in the function definition. So all the operations you do on this argument, rather this parameter in the function that you're defining as a callback, in the placeholder, the parameter. So this is the parameter. You take it in here as a parameter, and then you do operations on that parameter here. So the operations you do on that parameter are the ones that determine the criteria under which the function is, rather the array is going to be sorted. So for example, if I say the A is less than 50 in this case, what is going to happen is when the browser is compiling my code and it gets to this array, so when the 45 is brought here, it's going to be checked if it is less than 50. So if it meets the criteria, if actually it is less than 50, then it's going to be brought into my array, the sorted array, the filtered array. And if the second is checked and it doesn't meet the criteria, maybe it's 70. If the 70 comes and replaces this parameter, and it's taken in the algorithm for checking. So when it's 70, is less than 50. 70 is clearly not less than 50, so this will be a false and it will be discarded. Then the third element is checked using the same criteria, and then the fourth, and then the fifth. So only those that do meet the criteria, the condition that you put in the curly braces of the callback function, are the ones that are going to come as a result into this sorted array, filtered array. Is that clear? That's the rubric behind the filter function. The callback function takes in one argument, like you see it here. It takes in one argument. Then on that argument, rather one parameter. Then on that parameter, use the return keyword. On that parameter, it takes in, you put the condition in that parameter. That's the only purpose of the callback function to the filter method. So what is the criteria I want here? I want to find out if holder is less than 50. That's the only thing I want to do here. If holder is less than 50. So if I find out holder is less than 50, every number here that is less than 50 will be returned in my new array, which I am calling under 50. Let's first check the results, then go into a little deeper detail explaining that concept. Under 50s array. I'll use backticks here instead. So I'll enter it here under 50. Let's see what it looks like. So the array, I think, has actually been sorted. We had 1, 2, 3, 4, 5, 6, 7, 8. We had 8 elements. But in this new array, you can see all these numbers are under 50. But it was derived from the same array as this. It was derived from this array ages. Is that clear? So that's how the filter function operates. And you can reduce this syntax to something very simple by just removing all this and leave only and only the parameter name, then enter this equals sign and the quad angle bracket. And then instead of the return keyword, you simply put the condition. It's that simple. So that is also a function definition here, only that it is simplified. So there's a number of ways you can define functions. In this case, this is also a function. So I remove the brackets and I put this thing, okay, defines a function, and then the condition. It is simple, but that is also an accurate definition of the function. When I run it, it does give me the answers. That's the filter function. So if there are any questions about the filter function, because we're going to use this logic in the two other functions we're going to do, and all the other functions on the array, quite a number. Any questions, please? Okay. Damba, Paul, are we good?
Oh yeah.
Okay. So that's the filter function, and if we're good enough, then I can move on to the other functions. So I wanted to complete that before I can list the things that we're going to do on arrays today. So particularly on arrays, we're going to look at the map function. We've looked at the filter, so we're going to look at the reduce function. We're going to look at the shift, and the unshift. We're going to look at the push, the pop. These are all on arrays, and they serve different purposes. Slice and splice. So for arrays, this will be it, and then we'll move on to another object. Now, let me look at the map function. So the filter function creates a new array that is sorted according to the condition. According to a condition, yeah. Let me perhaps define it here. Put it here. Now the map function, it serves the same, uses the same logic, but does the array. It does particular operations on every element of the array, and those operations are still determined by the user. So this is what I would do. Let me type it here. The map method carries out operations on an array based on user definition. User definition based on the user definition. Keep it at that. So just like the filter function, we're going to use the same array. So as you can see here, the array under 50 is created, but if I try to check the original, I'm going to type it here, and the original, we're going to see if it's actually modified. The original is called ages. The original array is intact. It has not been touched. It's the exact same array as you can see it here. But all these numbers have been derived from this array. This array has been derived from this under the filter condition that I want numbers that are under 50. You can see all these are under 50, but we had 78 here, we had 89, which clearly don't meet the criteria of under 50. And that's how we filter the array. So if you're using the map function, on the other hand, if I'm calling it on the same array, now let me use a different array. Let me say perhaps use a different set of numbers just. Could even you put a string here. string, another array. So yesterday we used dot notation, but I think I may have to show you something else about. Okay, so I'm going to say let this array equal to that. So I have a new array, and this one has a multiple of data types, has numbers, it has a string, and has a nested array. So if I want to use the map function, this is what I would do. I would say this array. I want to do something a little tricky that will help us understand how these functions can be used together. So the function this array, sorry, this array. If I want to do a certain operation on each of those elements, still I'm going to use a callback function. And in this case, I'll call it hold as my parameter. And then what I want to do to each of these elements is I want to add a 3 to them. So I'll say hold as the parameter plus 3. So what that does, what this will do is it will go through the array, the map function, it will go through the array and pick each of these elements one by one, assign it to the hold parameter, and then do this operation on it and return it. Unfortunately, just like I said, map function is one of those functions that doesn't modify an array. So I have to store my results in a new array. So this is what it would do if I was saving it in a new array. I'll say maybe I'll say new this. What would happen is the map function would take the function that is defined inside of it and apply it this way. We'll get the first element, assign it to the hold, and then do this operation on it, and save it as the first element of new this. And then loop in the second time, takes the second element, assigns it to this parameter, does the operation, save it as second element. To the third, assign it to the hold, do the operation, assign it as third to that. So it's creating a new array, but an array that has been taken through this kind of processing, the kind of processing that was defined in the callback function. So it does that for all these elements, and then finally returns the new array. So let's see how this works. If I printed this on the console program and said then mapped array is a new this. So I'm saving it, and when I run it, string 3, sorry. Let me remove it so it doesn't be a distraction. So when you run it, you can see some difference. This was 34. Let me print them both so we can see the modifications. Say the old array. The old array is this array. So when you look at them both, you can see this was 34 became 37 after adding the 3, 21 to 24, 67 to 70, 34 to 37, 300 blah to that amount, 45 to 48. Now when it came to string, we did this yesterday. When we're adding strings to numbers, the numbers became strings. I don't know if I could show you something like that behind the work we did. Let's just probably do it again here. So if I had added a number, paid plus plus 5 plus 6 perhaps. I expect this to become entirely a string. When I run it, it has become a string. However, I know it's a string. These different data types are represented by different colors. You see, numbers are actually represented by a blue on our console program. And here, the 6 became black, which is the color that is used to define numbers here, rather strings. So it has become a string, and that's exactly what happened up here. When the hold, which was a string in this case, added a 3, so this will be the same thing. This whole thing became a string, just like this did become a string. And let's see what happened to the, let me expand this. This was 2, 3, 4, 5. This was 2, 3, 4, 5. That. Okay, this is what happened in this case. We had it was an array plus a 3, it became a string. So in this case, we had an array, the element that was 2, 3, 4, 5, first element, 8, second element. What happened in this case was, when we created a new array, it instead became a string. A string 2, 3, 4, 5, which is exactly the same as this, and 6, 5, 6, 8, 3. Can you see that? That is the same data type as the original, rather as the element that was on its left. So that simply tells us one thing about JavaScript that I want to prove. I personally didn't know this. I am just learning it now. Because we had an array, and when we added an integer to it, it became a string. So I'm going to try it out here and see if it is consistent. If it is not, then it's a concept I perhaps need to explore, and I would implore you all to look it up as well. So I'm going to add another array of this type, one integer, and see if it becomes a string. Array that was taken in, and then when I added an integer to it, it became a string, like you can see here. So I have an array and a string and an integer. Let me confirm it becomes a string. Let me check its type actually. Oh, it's actually true. When you add an array to an integer, it becomes a string. So yeah, I think it is wonderful. I've learned something new today as well. Yeah, and so that's how the map function works. It picks each of these elements one by one, and then does the operation that you've chosen, and then returns a new array. It doesn't modify the old array, it only returns a new array. And I could change this to any operation. I could multiply by 3, I could subtract 3 from them, anything I could do, but it applies to all the elements. The only difference between the map and the filter function is that the filter function creates a new array that has picked out particular elements according to the condition. So the condition that you put here in the filter function is supposed to be a condition that would return true or false for the different elements. The map function only does operations to the elements, like modifies the elements. So if you put a condition that requires it to check for values that are true or false, it will return for you true, false, true, false, true, false for each of them. So perhaps if I put, I was asking if hold is divisible by 3. How would I do that? I would say, no, let me use something simpler. If I say hold, if the value of hold is, I'm checking if the value of hold is equal to 20. In the filter array, rather in the filter method, it would sort the array according to this rule. But let's see what it does when I use it on the map function instead. You see what it does? It returns for you only the Boolean alternative of the result. So this is not equal to 20, so it will be there. This is equal to 20. Neither of these is equal to 20. That's why you see a false, 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 false everywhere. This is the difference between the map and the filter function. So if you use an operation that would return a Boolean value, like in this case, on the map function, it will return for you only Boolean values. But if you used an operation that will return a different result, perhaps a modification of the element that you are checking out, that you've replaced your parameter with, then it will return for you that new result. So that's the difference between the filter and the map function on an array. The filter function filters the array according to a Boolean condition. So here all I want is I was adding a 3. And that is how the map method was to operate. Any other question? And we've also learned something new, that if you add you get a string as a result. So I'm going to do something extraordinary, something that isn't direct. Now in this case, I have all these elements, and then I have elements on this side that are of a different data type. But I want to only add an operation, create an array that adds an operation that modifies only those elements, an array that has modified only those elements that fit a certain data type. So in this case, I have all these numbers, and I want to create a new array that has modified only the numbers and ignored the rest. So I'm going to use the filter and map function in the same statement. First, I want to filter the array so I can pick out all the other data types that are not numbered, and then do an operation on only those that fit the criteria. So after the browser has eliminated all the other data types and has left out only the numbers, then it will fill operation to those that fit the criteria that I have sorted. So if you want to do something like that, this is how you do it. So I'm commenting this out. Maybe I should put it up so we have the operational lines as the ones at the top. Yeah. So I have my array. It has numbers and strings, and then an array, a nested array. But here, what I was doing was creating a new array that modifies all the elements of this array according to this condition. This is a parameter, and when it takes the parameter in, it adds 3 to it. That means when it takes in each of these elements one by one, it adds 3 to them. But instead, I want it to filter this method, this array first, before it can do this operation on them. Or maybe I could do it the other way, that it does this operation on each of them and then filters out the numbers. But I want to start with filter anyway. So this is how I'll do it. I would say this dot array, then I filter. So I'm going to come back to this array and apply another method called the reduce method. So I'm going to filter out only those elements. Let me use E as my parameter in this case. Only those elements whose type is number. See that? So this is what it's going to do, this line. It's going to check this array and apply the filter method to it. And what does the filter method do in this instance? It takes each of these elements one by one, replacing it with the E, and then checks the type of the element and compares it to this. The data types, when you return them, when you're checking for the data types, the result it gives you is a string. That's why I'm using this in a string. So it's going to check the type of each of these elements one by one, and check if it is equal to number. Those that are not equal to number will be eliminated because I'm filtering it. And when it returns the new array for me, it's going to apply this operation to each of them. Actually, this is what it does. It checks if the element that has been picked from the array and replaced by this parameter is equal to the data type that I'm checking. And if it doesn't, it will discard it. If it does, it will take it into this operation. When the operation is done, it is taken and stored there. So it does the second, so it does the third, so it does the fourth. So it checks if it does meet this criteria, and if it doesn't, it discards it, and if it does, then it takes it into this operation where it adds a 3 to it. So it's like pick out one element from this array and check if its type is a number. If it's not, discard. If it is, then add 3 to it and store it in that array. You check the second. Does it meet the criteria? Yes, it's a number. Then you add 3 to it and store it in the array. Then it checks this. Does it meet the criteria? Is it a number? No, discard. Then does this meet the criteria? Is it a number? No, discard. So it is that simple, and you can put so many methods together depending on what you're doing. And yeah, methods can work to JavaScript one after the other. As long as the logic is consistent and coherent, they can work together. So let's see if this runs. Check the as you can see, the new map that has been returned, the mapped array that has been returned, has added 3 to only the numbers and not the string, not the array. The new array doesn't have a string, it doesn't have the array. Is that clear about the map function? Any questions? Okay, Ronnie, Maria, Paul. Okay, Paul, nice to know you're okay. So now we're going to look at one last method. Actually, not one last method, we have a few more. I think we had talked about them here. So we've looked at the map method. Now we're going to look at reduce, then we'll see all these others and move on to another object. So what the reduce method does is it reduces an array according to an array. This is the syntax. Most of these arrays take in callback functions. That's why it's important for you to understand how a callback function operates. When you're calling it, when you're defining it as an argument to one array. So I'm going to use, let me use this array, the new array that I defined, that I picked. I'm just going to save it in a new array. Reduce, let me call it reducible. And save the new array. So we're going to use that array, this array that was returned, this one. So pay attention. Now these are all concepts that I think you should pay attention to for those that are just starting, because you can store values in one array into another array. It's exactly what I'm doing here. So what I'm going to do now is I'm going to call reducible and apply the break. Else takes in, I'm going to use a different syntax here. Takes in what? A callback function. The only difference between the map, the reduce, and the filter method, the only difference between reduce and all those other two that we looked at, the map and filter, is that instead of taking in one argument, it takes in two arguments, rather two parameters to the callback function. So these two parameters are assigned on the callback function. And this is what it does. So we said it reduces the array into one number. Array into one number. According to an arithmetic operation. So let me demonstrate it here as well. Sorry, I don't have a better tool. This is the best I have for simple operations and demonstrations. Let me just delete all this. So this is what the reduce method does, what I'm going to show you in the next next 2 seconds. So if I had an array with different numbers, perhaps I'm going to use numbers so much because they're easier to understand. Different numbers in all these positions. What the reduce method does is it takes into it defines a callback function that takes into parameters A and B. So the filter function, rather the reduce function, takes in a callback function. When you invoke it, the reduce method, this method, it applies to only arrays. When you call it, it takes in function as an argument, and the callback function takes in 2 parameters. Okay? This is what happens when you call function. It takes the first element, okay? Yeah, sorry. It takes the first element here and the second element here. Let me change something here. Okay. Now the reduce method actually takes in 2 arguments. Just remember. Let me put a 0 here. I want to explain what happens. So perhaps I want to add these numbers and say I'm returning A plus B. Please follow closely because this one is a little different and a little more advanced compared to the other 2 methods. So what it does is, you see the 0 I have put here is going to be the first value of A. The 0 I put there, whatever number I put there is going to pick up the value of A. It's going to be assigned to A. So when you put the callback function, the second argument that you put in is going to be assigned. That is the second argument to the reducer method. This value is going to be assigned to A. And that A receives this value when you start doing operations on it here in the callback function. So this is what happens. When the A becomes the 0, in this case, could be any number like we're going to see, this B becomes that value, the first element in the array. And because I want to reduce this array to 1 value, adding A to B, A to B, A to B, until I have only 1 value left. That's why this method is called reduce. So it reduces the whole array to 1 value. In this case, this is what happens. The A takes up the 0 value, and the B takes up the value of the first element. So when these 2 are added together, maybe there's a 2 here, 0 plus 2 will become a 2. Now this 2 is assigned to the A, and the B takes up the value of the second element. So this second element will be added to the new A, which is a 2 now. If it was a 4, I would have 2 plus 4. And the answer to this is perhaps 6. This 6 will be added to the A, and then B will take up the value of the third element. So the new value of A, which was a 6 in this case, will be added to the third, to the value of B, the new value of B. Perhaps it was a 3. So I would have a 6 plus 3. This 3 will come here. Then I have a 9. So this 9 becomes the new value of A, and then B takes on the value of the next element. Is the pattern being clear now? I need some feedback before I can finish. So the A, okay, thank you, Maria. How about you, Paul? How about Ronnie and Lian? Kali, thank you very much. So this pattern is a pattern of, this is how the reduce function operates, the reduce method. The A is always the value of the result. So it's given the initial value, the initial value you want to give it. But when the first element is added to that initial value, the result of that operation becomes the A, then B takes on the value of the next element. So he's always picking new values, new values, new values. But the A is the result of the previous operation, and the previous operation returns a value which is used in the operation of the next calculation. So this A, in case we were at this point, the value, the aggregate of all these values, if I was looking for the sum perhaps, would be the value of A. Get it? And then the B will take up the value in this at this index. Maybe it's a 3. So if this was perhaps a 9, this would be 9 plus 3. And then we have a 12 perhaps. So this 12 will become the value of A, and then B will pick up the value of the next element. Until we come to the end, when there are no more values to number to pick up, then the absolute answer, the answer of the last computation, will be the result of the array. So that single array with all its values has been reduced to one number, one single number. And that's how the reduce function operates. So just to demonstrate it in code, so I had the array reducible, and when I reduced it using this callback function, which takes into the B, and then does this operation to each of them, taking in 0 as the first value of A, I should be able to get the answer now. So I'm going to save my answer into a variable called reduced, then print it. Okay, let's see what it looks like. Yeah, and the array I used was the filtered array from the previous operations of the previous array. So this is going to be reduced, and when I run it, I should be able to get a single value. Now that is the answer. You can use numbers that are more understandable. Maybe I'm going to change this. Let me use a different array now, something that is simpler. 1 and 2 and 3 and 1. I think this answer, you can already guess what the answer will be. This will be 1 plus 2, which is 3, 3 plus 1, 4 plus 3, 7. Let's see if the answer is actually 7 for this operation. So the answer to this is actually 7. Now, the reduce function can do so many things. I can even choose to subtract. So in this case, A takes the value of 0. So it will be 0 minus 1, it will be a 0. Minus 1, sorry, will be a negative 1. We can compute this in our heads and try to guess what the answer will be. And just to understand the algorithm of the reduce method. So this will be a 0 takes up the A first, then the B will be the 1. So A minus B will be negative 1. Then the negative 1 will become the A. And then B picks up another value, which is 2. So that's negative 1 minus negative 2, which is negative 3. Negative 3 becomes the A. Then B picks up another value, 1. So we have negative 3, which is negative 4. So we have the value of the answer of that operation become the A, and then the B picks up another value, which is a 3, which is a negative 7. That is what I think it is, unless I calculated wrongly. Let's see if it's actually the answer. It is negative 7, yes. So that is how the reduce method operates, and you can do all the other computations and even more on this kind of thing. So unless there are other questions, I think the reduce method should be okay. Any questions, any feedback, any additions, perhaps? Okay, nothing. I hope we're all okay. Now we're going to move on to simpler methods of arrays. Started with the complex ones because I'd already started using them yesterday, so I wanted to finish. Yeah, so those are the 3 major methods of the array, but there are other simpler ones, specifically those designed for modifying the array, and those just to pick out certain elements of the array. Let me comment this out. So what we're left with here is the shift, unshift, push, pop, slice, splice. Then we move on to something else. So let's look at this. Let's create another array, an array of numbers perhaps. Maybe let's use strings this time. Let's use apple. I'm going to use fruits. I'm going to call these fruits perhaps. Fruits, mangoes, oranges, peaches, and cherries perhaps. So we have an array. You can even check its length. You remember how to check for length? Okay, so all we have to do is just going to print it. Say fruits. The length. Let's see what its length is. Its length is 5, and you can see each of the elements at different positions. Just being redundant with the concepts we covered yesterday. So maybe I want to check the position of mangoes, rather the value at position 3 would be peaches, because this starts from 0. So this position 0, 1, 2, 3. That's where peaches is. Now we're going to use I'm going to start with some of the methods for left click. We're going to do push and pop. What these do is they add an element and remove an element from the last position. So push particularly adds element last array position. Then the pop from the last array index. Don't use the word index. Be consistent with index. So this is what I'm going to do. I would call the fruits array. Then if I want to add something to it, I would say push. So it's like you're pushing something onto the array. Maybe now I want to add a new fruit. Berries. So if I print this, let's look at it. If I print it again, let's see what it looks like. The array fruit. It has added berries to the end. Now, push is one of those methods that actually modify an array. Some don't, some do. Push is one of those that modify an array, and like you can see, it modified the array. So we printed the array fruits, and it had berries added to it. Now I can also print it again after I have removed. If I want to remove the last element of the array, I use the pop method. When you use pop, you simply call the method. You don't have to put an argument, and it will print for you, or rather it will remove the last element of the array. So when I print this, you can see the new array they've returned for me is like the original one. The name, the last element has been removed. And yeah, that is the push and pop method. And that's what they do. The push adds an element to the last position of the array, adds an element to the end of the array, and then the pop removes the last element at the end of the array. So now we're going to look at the others. The shift, and unshift. So the shift, the shift, this one removes an element in the first position, in the first index of the array. then the unshift removes and does the opposite. It adds an element at index 0. So let's test it with this same array. So we have the array fruits. Let's apply these methods to it. When I say unshift, and I add something to the start, maybe peers. When we print it, it looks like we have peers added at the end, at the start rather. This is unshift. This is pop. So I'm just putting the method names that have been used to derive these results, to generate these results. This is push. Okay. So let me look at it again. So you can see we had the unshift. It added an element to the start, another fruit at the start. Pop removed the berries, because when we pushed berries at the end, then pop removed it. Unshift added pears to the start, and then now all these are methods that modify an array, but then shift removes the first element from the start of the array. When we run it, you can see peers has been removed. These were 6 elements, they are now 5. Peers has been removed. But the array at the level of pop and the level of shift is the same. This added at the end, berries, push, and was removed by pop. Unshift added an element at the start, shift removed that element. So the last elements we're going to look at on the array is the slice and splice. Slice. They have closely similar names, but they do different things. So the slice deletes parts of an array. This does the same thing, but this also enables replacing. It enables deleting and replacing. So let's look at each of them. We're going to use the same array fruits. So if I say fruits, fruit, let me use slice first. What it takes in is a number, and what that number represents is index at which you want to begin the moment. So by using function as a constructor, yes, someone talking? Yes, we are. Okay. So a function as a constructor, every object that is going to be built or constructed with this function is going to be it's going to be represented by the this keyword. So all the properties on that object are going to have names with a this keyword before it, because this function is being created as a template for all the objects that are going to inherit the properties and methods that I'm going to build with this function. So later when I create an object with this function, the object takes up the place of the this keyword. So that this keyword in this place is going to be used as a placeholder, just like we're using different words for the parameter. Different words for the parameter, yes. As placeholders, in this case, let me give you an example. Like when I was defining this function and this function, I used the parameter placeholder. So it's just like a container, or yes, a placeholder. So even in this case, this keyword is acting as a placeholder for the objects that are going to be using, that are going to inherit the template of this function as a constructor. So perhaps I'm defining a constructor for students, and I'm saying this dot name. What this means is that the objects that I'm going to create are going to have the property are going to have the property name. So if I put an object like Jesus, so it will be Jesus.name. Or anyway, we'll see that in detail. So that's like the name or a key value. Like we said earlier, objects are designed like this. There's a key and value. There's a key and value pair. They are designed as key and value pairs. So we have another key and value pair. So we that. Okay, this is supposed to be value. Let me just remove this. Objects are just bundles of key value pairs. Is that simple? Just like functions are bundles of code, objects are bundles of key value pairs. So in this case, I'm designing a template for how to create a particular object. So, and this is a constructor function, the template from which they're supposed to inherit their, let me say their properties. So this function can take in arguments as well. So maybe when I'm creating an object, it has to have a name and an age. But that name and age are supposed to be bound to the object. And how I bind them to the object that is going to be created is using this keyword. So this keyword is supposed to represent every object that I'm going to create in this constructor. So the object takes in the variable name, rather the argument, the parameter name, and the parameter age. So the name that I enter here is going to be stored as a property of the object. Then the age that I store here, this dot age, for it to be a part of the object, I'm going to store it there. So now that's my constructor. See, so here for the first student, and I will name it Maria perhaps. So I'll select Maria. Now when you're creating an object from a constructor function, use the keyword new. So I'm creating a new object from which constructor function, the function called construct. Does it take in any arguments? Yes. What is the first argument? The first argument is name. And I'm saving the name Maria here now. Maria. And then the age may be 34. Okay, so I have an object now created. So if I want to check if the object Maria has, maybe I want to check the name that has been stored in the object Maria. I'll just print it like this, console.log, and then type the object name and dot the property name. So I want to check the age, and I want to check the name that has been stored. Let's see what the answer is. The answer is 34, Maria. I think it works now. So now this keyword in this case has been replaced by the object's name Maria. So when I try to check if the object Maria has an age, the age was already being displayed for us here, it's 34. And the name has been displayed for us as well as Maria. So when you're using a function as a constructor, when you want to save any calculation that you're doing inside the function, or any argument that you're passing into the function, and you want to save it as a property to the function, this is what you do. You use this keyword before you type the property name, because this keyword is being used as a placeholder, because now I can create another object using the same constructor function and say maybe Timothy. So I'm creating a new object using this constructor function, and I type my constructor name, then the arguments that is taking. The first argument is name. I didn't specify the type, so I could say maybe the name is Timothy, and the age is 4. So I'm going to print these values again, but for a different, I'm going to print these values again for a different object. Object name is here. So when I create a new object, the object is saved in the variable here. So now this is an object. This is Timothy. And this is Timothy as well. So let's see what the result is. The age is 4 and the name is Timothy. So basically that's what a constructor function does. And as you can see, I used it as a template for creating these objects. But wherever there was a this, there's been a replacement with the object's name. So in the template, this would have been like this age. But now when I created an object, that this was replaced with the object name. So this is now Maria.age. And this is now Timothy.age. So when you want to save a property to an object, you use the this keyword before the property name on the object, rather in the constructor. So that when you use that constructor to create the object, it applies whatever you're applying, whatever you're saving into the property. Now, like we said, an object is a bundle of properties and methods. So now we have properties so far, but we don't have methods. So how would we add methods to each of these objects? Something, okay? Yes? I can't hear you.
Okay, that's okay. Like this dot name. So what is that name? Is it the argument or
okay?
It's the
okay. So we had a constructor function here, and it's going to be used as a template for building objects. But the constructor function takes in arguments, name and age. So when I'm constructing the objects using itself as a constructor, what I enter as the arguments are saved as properties to the objects which I'm creating.
Okay.
Is that clear?
Okay, let me say, so this is this dot name equals
Yes. Equals name. So this is the argument that has been entered, and it's being saved as a property to the future object.
Thank you.
Sorry. Now, how do we add methods? Like we said earlier, objects are just a bundle of properties and methods. So we're going to add methods to each of these objects using the same template here. Now, when you want to add methods to an object, this is the point where I have to explain what a prototype is. So instead of adding them here, this is what I would do. I would type the constructor name, then type the word prototype, and then the object, rather the method that I want to add. Maybe I want a method that just prints, maybe adds 1 to the edge, to the property edge. I'm going to call it edge changer. So what I'm going to add here is a method, so it has to be a function, and I'm defining the function now. It's going to be stored in the variable edge changer, and when I define a function, edge changer will become a variable. I'll explain later why I type prototype here and edge changer instead. So I'm going to call define a function, and just return. Just do the calculation, then return the answer. So I'm going to add 1 to the edge, this dot edge, which is already a property like we've defined it here. So I'm adding 1 to the edge and then printing the result. Now say your new edge is what this dot edge is now after the calculation has occurred, because this is all happening inside a function. Remember when we said a method is a function? So now this is proving it that a method is actually a function, because I'm defining a method here, a method on the constructor, which eventually is going to become a method on the objects. Yeah, this is this dot edge. This dot edge. So let's see. Now I've defined a method on the constructor. So the constructor, a method creator for edge changer as a template, because this dot edge, when I create this object, this function is going to be added onto this object, but this for Maria is going to be replaced with Maria. So wherever there's a Maria dot edge, this operation will occur. When I call this method edge changer, it will get Maria dot edge, first add 1 to it, then print for me the result. Let's try that. Let's see if we call this method, what happens. I'll just call it because it already has a console log, so I just have to call it. So I'm calling Maria dot edge changer as a method, and let's see what it prints. Because Maria's age right now is 34, so I would expect it to become 35 here because I'm adding a 1 to it. Sorry about this, just get rid of it. So when I print it here, edge changer, it says your new age is 35. Does that make sense so far? When you're adding now I'm going to explain what a prototype is. So in JavaScript, like we said, almost everything in JavaScript is an object. So we're using this object. A function is an object. We're using the function constructor as a template for creating these objects. Now, because we're using it as a template, we can create as many objects using this as our template. But we have to use something that exists as a placeholder for the different objects if you want to do calculations. Like that's what this keyword is there. So this keyword represents the future object. So wherever there is this, when I create a new object, this is represented by the name of that object. And what I was taking in as arguments, these are changeable for every object construction. So what I'm saying is, when you enter the word Maria in the construct, and you're creating an object, may that the second thing, if I enter the word Timothy, may that word be taken as an argument, rather as a value for the property name on that object Timothy. Is that clear? Now for the methods, you add them on the prototype of the objects. So this is what a prototype really is. Let me actually just print it here so that you can understand what it is. I can move this out first in this. So I'm going to print. I'm going to print the function construct. And you see what it actually looks like. For one of these objects that have been created from it. Maria. So what I'm doing here, I'm just displaying the objects themselves. So you can see, let me print this also. I have three things I'm printing here. I'm printing the constructor and the objects that have been created from it. Let's look at what it looks like here. So I have a constructor, and these are the objects that have been defined using it. Two objects. One has a name, one has the property, two properties, name and age. The value of the name is Maria and the age is 34. Then the second has a name, Timothy, and the age 4. But you can see when I defined these objects, we had a value, this.name, in the constructor. Now that this.name has been replaced by Maria.name. Although it's not showing me the name of the objects here. It is instead showing me the name of the constructor from which they were created. You see that? Now what that means is that this construct function is a prototype. What a prototype is, in English, simply is a template from which something else is created. And clearly this tells us that these objects were created from the construct function, the construct objects, as their template. So what we're going to now, you see why it reads prototype here. It also tells us the prototype is an object. Let's look at the prototype of Maria. When you look at the prototype of Maria, it has the function. It tells us that the constructor of the object was that construct.name. And then it also has the method age changer. You see that? So that means that from the prototype, in this prototype, everything that was within it has now become a part of a part of this object. So like I said, what a prototype is simply a template from which another thing is created. So the prototype of this object is the construct. And when we add a method to when we want to add a method that is applicable to all the objects of a particular constructor, we add it on the prototype of the constructor. And that is the reason why we do that, like we did it in this case, is because when we add it, let's see what happens when I do this, when I remove the prototype. I hope this isn't very complex. Are we following? Some feedback, please. Okay, thank you very much. Probably have enough time to cover a lot of things, but what was that? The change of it. I want you to notice something here. When we added the edge changer method on the prototype of this constructor, it was visible in the objects that were created from it. Now it is not visible. Now what happens is when you have an object, a function constructor like this one, in itself it cannot contain methods. They have to be added on the parent object that created it itself. That's just how JavaScript works. So that is why when I add the prototype here, which is the parent object of the what? Of each of these. Actually, maybe I should just use paint to bring it out well. Now this is the core of inheritance in JavaScript, so I want us to get it very clearly. We have constructor here, and it's going to be used to create objects 1 and 2. Now each of these is going to inherit the properties. These are properties now. They're all inherited from the constructor. And like we've seen, when we try to find out, look at each of these objects, instead of showing us the object name, it was showing us the constructor from which they were derived, meaning they are connected to this as their parent, which is also an object. Although there are two ways to define objects, we shall look at the other using the class keyword. So this is the constructor, and it defines objects. They take the parameter rather than the properties. So now what we're going to look at is the methods. Why do we add them to the prototype? Because if I add a method, this is what is going to happen when I use this keyword, when I don't add the word prototype. Precisely what I'm saying is, this is an object, and that is a method. So every object has a prototype, and the reason why it does have that is that there are elements that have to be transferable, methods that have to be transferable to children, and they're only transferable if they're added to the prototype. Because sometimes, just imagine, I'll give an example of an organization. So in an organization, there are people who you want to be administrators, and there are people who you don't want to be administrators. So there are things that you will want to share with everyone. Maybe each of them should have an ID, each of them should have an account of their own, maybe on the platform of the organization. But the administrator has things that are supposed to be unique to the administrator. Maybe they have an all-access key, which not everyone has. So when I use something like this, like construct.edgeChanger, if this was to be the object, this would be the object that only has edgeChanger. But when I put something on the prototype of this object, you won't see it with the created objects as well. When I put this on the prototype of the object, then it's accessible to all the children that are created from this object. You understand? Like you put someone in charge of your organization and they're supposed to share everything. Maybe for every employee that comes in, they give them a shirt, they give them an ID, they give them this and that. Now, those are things that you would put in the prototype of the object. Maybe if it was an administrator, those are the things that they will be allowed to share with everyone else. But if I remove this from the prototype and add it on the administrator himself, like I give a particular ID to the administrator, and it's supposed to be shared by no one else. Even the parents, rather, even the children that are created from that object should not share that entity with the administrator. So what I mean is it's exclusive to the administrator. So anything you add directly on the constructor object is not accessible to the objects that are created from that constructor. But everything you add to the prototype is shareable with the children of that constructor. Object with this as a constructor, everything that is within the prototype of that constructor is accessible to all these objects. But if I remove it, like I did here, you can see when I check the prototype, it tells me yes, this object was created from the constructor construct. But I don't see the methods that I added to construct. You know why? Because they are exclusive to the construct object. Although it's a function, we shall see how it is similar, objects and functions, how they are actually the same thing. Everything that I added to construct and not to the prototype of construct is not accessible to the constructor. But let's see here. When I open the constructor itself, it has the method edge changing. You see that? Now this is the object that created these objects. In itself, it has edge changing, and it's exclusive to it. That is why I cannot access it here. But when I add it to the prototype of the constructor, then the children can also share. When I open this, you can see that on the prototype of the object, edge changer is shared by all the objects that were created from the constructor. The prototype, which is the template from which these objects were created, and that's why it's the prototype and it's an object. When I check the constructor, okay, it's there. It is here, edge changer. It also exists on the construct object, but also the children have a share of it. So now let me call this method and see what it does. Edge changer, when I call it on Maria, I hope that concept was clear. When I call it on Maria, when it's added to the prototype of the constructor function, it gives me 35. That means it adds 1, because that's what the edge changer function is doing in this case. It's adding 1 to the edge, which is a property of the objects here. Adds 1 and gives us the next edge. Or if I removed it from the prototype, let's see what happens. Does it work? It says Maria accessible to the children. The children, in this case, children are just the objects created from that constructor. It's not accessible to them. But for it to be accessible, I have to add it to the prototype of the constructor of those objects. I hope we are at par with this, and I think it's working. So now, unless there are any questions, I want to look at inheritance a little more deeply. Okay, so we have that now. We've been looking at inheritance at a level of construction, function object construction. Now I want to look at a much deeper level. So maybe let me look at this keyword first. So this keyword, like we used it here. So this keyword, it has a number of ways it can be used. and I'm going to look at them all. It has about 4 ways it can be bound to an object. The kind of what I'm looking at here is what they call the new binding. So let me put it up here. Here we're looking at this keyword, and we're looking at the new binding method. And then I want to look at another method with which we can use this keyword. And that's what they will be called explicit binding. New binding, it simply means you're using the new keyword to create an object, and the name of the object that you've created will replace this keyword wherever it is from the constructor, whether in the properties or the methods of that constructor. So wherever there's a this on the methods and the properties of the constructor, the name of the object that you've created will replace this keyword. Now that's what they call new binding. That when you use the new keyword, the name of the object replaces this keyword, and is used in the operations that are being done by the method and the properties of the constructor. So let's look at explicit binding. What explicit binding is, you have a function that has a purpose, an object that has a purpose, but you can change the context in which this keyword is being used. Let me just define a function here. Let me just call it admin. So admin, the function admin in this case, has a property employee and has a property employee status. So what I'm simply saying, there's an administrator in an organization, and they're responsible for employing someone. The name of the person they're employing is stored in the employee property. So I'll take the name, and then the status, has the person been employed or not? Employee status. So we have status. Yes, now we have two properties, and I'm going to define a method here. So because I want it to be applicable and accessible to all the employees that I'm going to create, I'll put it on the prototype and name it status change. So it's a function. I hope I'm not going so fast. It's a function, and what it does is okay, it gets maybe hello. Yes, please. Hello. Yes, I can hear you.
Hello.
Yes, I can hear you now.
How do you get to know those properties? Like those prototype properties. Do you first look at the prototype, like in the console?
The prototype properties. Now I'm just defining. Okay. What is default in this case is just the word prototype. This is user defined. The method name. I can give this any name. It's just like a variable, but I'm assigning a function to it. This is just where I'm saying it as part of the admin constructor function, in the prototype of the admin constructor function. But I can give this any other name.
All right.
I'm even call it a start change. really anything. So in this function, so here I wanted to take in something like an age as well to create some kind of criteria. So I'm storing the age that I'm entering here, the variable that I'm entering here is age into my property age. So I've defined the property age. Now that means that all the objects that are going to be created with the admin function, with the admin object, that this keyword will be replaced by the name of the object. So if it's like the name Vian, if I'm creating an employee named Vian with the admin constructor, this will be Vian.age at the point where I use the new keyword here. So if I put the name Vian here, where there was a this in my constructor, there will be Vian. And what am I storing in this property, Vian.age? In the case of the object construction, here I'll put the variable, rather the parameter, the argument that I'm going to enter when I call this function as an object constructor. So what this is going to be here, perhaps I want to ask a question. I want to look at the if statements. So here I'm going to just put an if statement and say if this age, in the case of Maria here, if the object was already created, I would say this would be something like Maria.age. That means if I'm calling this method on the object Maria and running it after the object has been defined already. Now here, when this method is called on the object that is defined from admin as a template, as a constructor. So I would say if this .age is less than or equal to 30, then we're going to modify this .employee, because what I want to do is that I want to employ only people that are under the age of 30. So I would say something like this employee status should be employed. Now say else. Employee status declined. So the employee status is going to be determined. Let me remove this because I just want the name and age, and then the status is determined by the if function. So I have to call this function whenever I want to modify this. And now I'm going to create an object using it as a template. So let me create one template, one object here. Ronnie perhaps. Now this is now an employee I'm trying to employ. So I'm creating an object using the new keyword and calling the admin constructor. So what arguments does it take in? It takes in the argument name. So this is Ronnie. And what is his age? His age is maybe 23. Then I'm going to create another object. Maybe Simon. I'm creating the new object from the constructor admin is. okay, man. I will change it to 21. So another name, Simon here. And then maybe 35. So I have two objects here. And so for me to establish the employment status, I have to call this method start changing on each of these objects first before I can call the employee status to know if they are employable or not. So I'll call Ronnie. So is that the name? I'll call call Ronnie dot start changing as a method. Then I'll also call Simon dot start changing as a method. Then later I just want to check if each of the employability status of each of these guys. So I have Ronnie, and I'm calling employee status, and then I'm also calling Simon dot employee status. So let's see what it looks like. After I have called the start changer method, it does this operation, checks if their age is below 30, and if one of them is below 30, if a person is below 30, it will change the employee status to employed. Otherwise, it will say they are declined, they can't be employed according to my criteria, my stipulations. It says employed, declined. Maybe I should put something here to clearly show this. So this is Ronnie. Ronnie was age 'age. Now I'm calling the property Ronnie.age here. So I give me Ronnie's employee status. And then for Simon, I call Simon.age. Now let's see what happens after I get this. Did I miss out? Yeah, comma here. So it says Ronnie was 21 and their status is employed. Simon was 35 and they were declined. Is that clear? But this only works after I have called these methods, because they're the ones that determine the age. When I determine the employee status, you can see before I call them, because I've commented them out, the employee status is undefined. So it's computed automatically when I check the age. And that method is accessible to all these objects because it was added on the prototype of their constructor, the constructor admin. Otherwise, if it was removed and added to the constructor itself as an exclusive method, that means all the children that are going to be created from these objects, this function, cannot access that method. And when I try to run it at this point, it says run is start changer is not a function, simply because it's not accessible to the children of this constructor. Now, just like this constructor has a prototype through which it shares its methods to the children that are created from it, to the objects that are created from it, as well, it could be inheriting some of these things from somewhere else. So we're going to we're supposed to look at explicit binding, so I wanted to concretize this concept first before I can look at explicit binding. Now I'm going to comment this out. So I'm going to start changer, the new admin, all this, so I'll be left with the constructor itself. So now I have a constructor, but I want to look at a context in which I can apply it. So it is just an element, a bundle of functionality which has properties and methods. Only one method for now, start change. If I want to add another method, I simply do the same thing, maybe admin.prototype and then the method name. So explicit binding is something like this. Maybe I have a function that does an operation like this one does. And I want to call it on, let me see the best way to do this. Okay, let me define another function. objects. I'm going to use a simple employee, Joseph. Now Joseph has a name. The name is Joseph. And the age, Joseph's age is 33. So now what I'm going to do is, I have an object, Joseph, but I want to apply the functionality of this constructor, of this object, into Joseph. In each of these, in this constructor, it will be replaced with Joseph as the object name. And this is how you do explicit. Rather, if you have an object already created and you have functionality that you want to apply, this could apply in something like JSON files. Maybe you had a JSON file fetched from somewhere, but you have a function that you want, whose functionality you want to apply to some of the elements in that JSON file. This is how you would do it. Just imagine the name Joseph was. Let me actually just change the name and call it JSON. JSON, like a file that is passed already, one that has already been passed from the JSON format and is now an object, a JavaScript object. For those that have done JavaScript, a JSON file is just a format in which you transfer information from your computer maybe to another service. So if you have an object like this, if you want to convert it to a JSON file, just to show you how that looks like, so you can understand this concept I'm about to explain. Console.log. So if I have an object like JSON passed, we'll do something like this. Let me put this down. So I'll say JSON. This is actually a JavaScript class called stringify, and then passing this object. So it's converted into the JSON format. Let's see what it looks like on the print. You can see what a JSON format is. Some of the rules are simple. Everything that is a string has to be in double quotes. Now this is JSON format. But if I want to, okay. Then now just imagine you are picking a file like this from somewhere, a file like this from somewhere and storing it in a variable, and then turning it into a JavaScript object. So it looks something like this. So in your program, after that file has been, where it has come from, now you want to apply the functionality of this function or this constructor or this object creator onto that, something like this. So you have an object and you have the function. You have the object that has the functionality that you want to apply to some elements here. This is what you would do. You would use a concept called explicit binding. And how you do it is, first of all, you type the object's name, the object that you've received. In this case, my object is, after I have passed it, passing is simply converting it from JSON format into JavaScript objects. As we go deeper, I think we may have time to look at these files. So I would say JSON passed, and then use the .call keyword, and when you're calling it, what you're actually calling is that function that has the functionality you want to apply on your JSON format, on your new file, your new object. So what's the name of that? The name of the function is admin. Okay, so let me save this in a new file. Maybe let me say applied. Let's see what this would look like. Admin applied. So that means every property, every parameter here, every property and method that was defined as a template on the admin method, an admin function, now accessible to this object. That means JSON.pass has replaced this keyword. So we have JSON.pass.employee. Do we have employee here? Oh, sorry, I should change this to employee so you see consistency. Employee age. Now, when I come down here and say, I'm just going to print the name in this case. I'll say, sorry, this should be admin. Say admin applied dot employee. I should be able to get the name Joseph. Sorry, let me look at this and see. Supposed to start with this. Okay, because of time, I don't know, there's something I think I'm missing out here. Yeah, but I'll figure it out and then post it in the Telegram group. I don't want us to waste a lot of time on it. The other thing I wanted to talk about beyond explicit binding is the default binding. What that means is that when this keyword is not referring to an object through the dot keyword, through the new keyword, and through this method that I wanted to look at here, which is the call function, it is referring to the global state of your program, and we're going to look at it. So if I call the function randomly, let me call this same function admin. So the function admin, in this case, I'm just going to call it as admin. Normally, as I would call a function admin. So when I call the function admin, it takes into arguments. I think I should, let me keep this no. Let me create another function for clarity. Function default. So I want it to have a property, this dot time, that takes in a variable time, which is defined in a global scope. Time equals maybe 45 hours, the string. So when I call, maybe when I return the value of my print this, and say the time is, and then put in the property name, this the time, I will end up doing something like this. When I call this function, this is what I will receive. Let me call it and see what it gives me as a result. Just yeah. Okay, I'm thinking of the best way to explain this concept. Okay, let me first bypass this default binding and explicit binding. I think it's one of the things I will do tomorrow when I have a better explanation. Let's just look at inheritance more deeply. Okay, so although I hope so far everything is clear, beyond the two things that I've just decided to bypass for now, I hope everything is clear. Some feedback, please. Have we at least understood what a prototype is and how to use them when you're defining a function? Okay. So now I want to look at inheritance more deeply. So I'm going to put this a new file so that this is easier for us to understand. I'm going to put it in a new file and explain it separately. Okay, so I'm going to use this and change the file to inheritance.file. Okay, so I have my function here. This is the same function from the previous file. I simply shifted it. Now I want it to inherit. I want another function here to inherit properties and methods from this function up here. So maybe employee. And it has a property, this status. No, compensation, let me just say salary. So it takes in an argument, for the salary, takes in an argument for the name, it takes in an argument for the age. So his salary will be equal to the value of salary we can store here. Okay, I don't know if we're moving at the same pace or can we take a break of like at least 4 minutes? Is that okay? Give me a thumbs up if you think that's okay. 10 minutes. Wow. Okay. Okay, yeah, we can take a break up to 8. Let's take a break up to 8:18. Let's do it up to 8:18. So because we have very short time left to the end, so let's take it up to 8:18. If you have any questions, you could please ask right now. You also give me time to understand why that thing hasn't worked, so I can look at it now. Okay, you're all welcome back. I hope that was a wonderful refresher for you. So, just something to look at. Was still, I don't know why on this file. We're looking at this file. So what I wanted to do was all this information carries all its functionality so that this keyword is represented by the objects I'm going to create by this employee function. Okay, this is what I'm going to do. You get the name of the function that you want to use as your parent, as your prototype, which in this case is the admin, and then you call it into every object that is going to be created by this function, by this constructor, using this keyword. So that means this keyword is going to represent every object that is going to be created from this employee constructor, and then we'll call every object, rather call all this functionality down into itself. Now, after entering this keyword, you're supposed to enter all the other arguments, and they will be applied as arguments to the admin function up here. So you see here, I was asking for the name. So this name, if I put it here, when I enter it, it's going to be applied now as a parameter. Okay, when I create an object with this function, with this constructor, the name I enter here is going to be taken as an argument by the admin constructor up here, because I put it as an argument to the call of the admin constructor. So it's like I'm calling all this functionality to be down here, and everywhere there's a this is representing this constructor. And every object that is going to be created from this constructor will replace this. So if I have an object from the employee constructor, something like Daniel, it's going to be Daniel.salary or Daniel.employee, Daniel.age, Daniel.employee status. I hope that is clear. So it's picking all the properties and methods from the parent constructor, which is now going to be the prototype of this. Is that clear so far? Okay. So name and age. Now these are all the parameters, rather the arguments that I'll be entering. So I have my object here, and yeah. Now, what this slide, that line does, it only and only inherits the properties. There's a different way we inherit the methods, and we're going to look at it. So what you do is, if you want all the properties, all the methods on the parent prototype of this constructor to be accessible to the objects created by this constructor. So we have constructor 1, which is now the prototype to constructor 2. The parent constructor is admin, the child constructor is employee. And we said if you want all the children of a constructor on the parent constructor, you put them in the what? In the prototype of that constructor. But the method that we want to inherit in this case is on a chain of inheritance. It's higher in chain. So we have the admin constructor up here and this method here. Then we have the employee constructor here. So we want the children that we're going to create to inherit this method. But it's not on the employee constructor, it's on the parent constructor to the employee constructor. So before we do this, let's first create an object using the employee constructor and see. So I'm saying emp Daniel, just to mean employee Daniel. I'm creating a new object with it, the employee constructor, and then passing in all the methods. First of all, what is his name? His name is Daniel. What is his age? Is 23. What is his salary? Maybe $250. Now that's the object. If I want to access, let's say console.log, if I want to access his name, I'll simply say emp Daniel dot employee. So I didn't use the word name, I used the word employee here, employee, to replace name, but I can change it, although it will require me to change a lot of things, so I'm not going to touch it. Actually not, maybe I can say employee name. Yeah, so wherever there's employee, I'll just change this to employee name. So I have Daniel's name here. But what if I want to access this method here, start changing? For me to know Daniel's status, let me try to access his status as well. So let's say the employee name. And here I'll put the status. Yes, so let's run this and see if it works. Or maybe I should also access the start changer, or at least try to see if it actually works. Start changing. So let me put this above so that it first runs, then we can check the status. Uncalled reference 250 is not defined. Just a moment, let me close this. 250 is not defined. Oh, salary. It's supposed to be a string, sorry. Employee start changer is not a function. That's what I wanted to see, but the others show. It shows me the name is Daniel, and where it failed was when I tried to access the employee, the start changer method. And we realized employee Daniel is an object, yes, but it was created from using the employee constructor, which is ideally supposed to be a child of the admin function, the admin constructor. And how do I know that? I started by accessing some of the properties. Hello. Okay. I started by accessing the admin constructor up here and picked all its properties, the property name and the property age. As you can see, the employee constructor doesn't have a property age here, or even the property name. Down here, when I called employee.daniel, employee Daniel.employee name, because this is the object name and this is the property name. When I called the employee name, I was able to have a result here, name.daniel. Let me put that there. So I was able to have a name Daniel. That means all the properties, the property templates from the admin constructor have been accessed by the employee subconstructor or child. Now this is the prototype chain. This is the prototype, and this is now the child inheriting from the prototype, from the parent. So now all these objects are now also inheriting from this object. What they are not inheriting is this method, start changer, because it has told me that start changer is not a function, and and that is because it is not accessing it. So, like I said earlier, if you want all the children of an employee constructor to access the constructor on the employee constructor, yes, on a parent constructor, you put them in the prototype. So what I'm going to do is I'm going to get an object. I'm going to create an object to be the prototype of this employee constructor. And that object is going to be the prototype of this constructor. So that's all the methods that are here are now accessible in the prototype of this. Why I put them in the prototype is because I want them to be accessible in the children that are being created by that constructor. So I'm going to say object.create and get the admin prototype. This captures everything in the prototype and we'll put it in the prototype of this employee constructor, which means they'll be accessible to the children. Let's see if that actually did something for us. I think it did, because now I can take the status of Daniel, although instead of putting status, I put employee status. So we can tell that Daniel's status is employed because his age is 23, and we said in this constructor up here that we only and only get taken people whose age is below 30. So perhaps I change his age to 50. Let's see what happens. Sorry. His age is okay. Because his age is 50, now his employment status is declined. We can no longer accept him because he's above age. Now his salary, if I want, I can print his salary because it's a property on the employee constructor. So it's a property now on all the objects that are being created with the employee constructor. Like one of them is this one. So maybe I could enter another person's name if I want, another employee. Select Tennyson. Put another object with the employee constructor and say name is Tenny. Is maybe 12, and his salary is $345. So now I want to access, let me first change this. Tennyson, and the employee status, that of Tennyson. But not only access that, but I also want to access his salary. Say salary now. What do I see here? It's $345. His status is undefined because I haven't run it on. Lloyd. Yeah, so essentially that's how inheritance works. There are so many things I wanted us to look at today, but because of time we haven't been able. So I think maybe we'll look at them tomorrow, and I will start with these things, these elements here that I wanted to look at. Maybe I could actually do this one now. Let me explain the concept I wanted to explain, then I come back to that. Okay, so this was inheritance I was looking at here, and just to illustrate it, let me do this. So we have an object here. We had an object that was called admin, and we were using it as a template. We're picking all its properties to create another template for creating objects called employee. And then all the other objects that were created from employee had access because we called the properties from admin into employee. When we did that, all the properties were now accessible to all the objects that were going to be created by the employee. What wasn't accessible were the methods. The methods now had to be called onto the prototype of the employee. The prototype, all the methods on the prototype of admin how to be called onto the prototype of employee to be accessible to the parents, so that to the children. If I get a method and store it directly on the constructor and I put it here, the children will not be able to receive it. This is the only mechanism by which JavaScript ensures security. At this level of, I just want to give an analogy that will explain this better. So, like I said earlier, we have an administrator and we have employees. So, if you want them to share certain properties with the administrator by being as being part of the employment for the people that are employed in the company, you put all those methods on the prototype, so there will be access to the children. But if a property is directly on the constructor or on a function or on an object, because a function is actually an object in JavaScript, when it's directly on the object, the method, it is not accessible to all these children that are created from it. That is why even when I was creating an object here, object.create as a prototype for this prototype, rather as a type of employee, the prototype, I had to pick it from the prototype of the admin. So that's all the methods that are on the admin's prototype are accessible here in the prototype of employee. Otherwise, all the methods that were directly declared on the admin. Let me actually demonstrate this. That were directly declared on the admin constructor, they will not be accessible on the prototype of employee. On the employee prototype, they are not accessible. So if I have admin the prototype, and this is where I put my start changer. So if I had another method, and I put it directly on the admin this time, on the admin constructor, and I didn't put it on the prototype of the admin, and maybe I say, what am I looking for? Edge print. So this one just prints the edge as my method. And I just put it here. So I say, maybe just return. Perhaps just return for me. Solid log. The edge, I hope you can all see the edge of the student or the employee is. So now I would expect to print the object name first, represented by the disk, since I'm now creating a template, and then say the age. Let's see if the object we created with the employee constructor can actually access this property, this method rather. So in this case, I would say, since it's already printing in itself, I don't need to put a console log. So if I say Tennyson dot, what's the name of the age print? .age print. What does it give us? Defined using the employee constructor, which also accesses all the methods that are available from the admin constructor as its parent. But this one is not available first of all, to the objects created by itself as a constructor, and also to the objects created by its children as constructors. Even to the constructor itself, the child constructor to itself does not have access to those methods. To this method, perhaps, this one, for instance, because it's not put on the prototype. Only the methods that are on the prototype of a constructor are the ones accessible to its children and to the objects created by its children, or even to the objects created by itself. So that means if I created a new object here, let me put it down here. And say maybe admin. that admins. Sorry, that constructor. It takes in a name. Let's say admin Michael. So now this is an object being used by the absolute parent in our file, admin. When I name it, give it a name, maybe Michael. Are you taking any other argument? The age of Michael, it's maybe 45. So when I try to access that property, that method, admin Michael, but age change, where is it? Age print, sorry. Let's see if it also accesses it. Okay, this one failed. Let me just remove this and see if it continues. You see, even admin Michael isn't able to access it, yet it's actually created on the object that has that property defined within itself. So the problem was I didn't add it to the prototype. It's only on the prototype that a constructor can share its methods. Using the call keyword, like we did, using the call keyword, okay, for the properties, they can be shared if they are defined within the scope of the constructor. But the methods cannot be shared if they are not put on the prototype. It's only through the methods, rather through the prototype, that a constructor can share its methods with its children and with its child constructors. Like in this case, the employee constructor will be able now to share this method because it's been added on the prototype. Let's see if these two methods are able to access. Yeah, if these two functions are able to access, is the print is not defined. What is this? Each print is. Let me see where the problem is. So we haven't saved yet. So we can see they are both able to access it. This one tells us that the age of Tennyson is 12 and the age of Michael is 45. Now that's the concept I wanted to share last. I think right now I can't start on something new, but I appreciate your patience. And if there are any questions, I would love to receive them now so we can perhaps concretize these concepts. Thank you very much, Bian. Well, so for tomorrow, I don't know if Bian can give us a program. Are we doing a bit of JavaScript tomorrow still? Because there are still things I think we need to understand, like asynchronous processing. And yeah, also generally asynchronous processing.
I think tomorrow, am I audible?
Yes, you are.
Finish up with JavaScript. Maybe in case we still have some time, we can do some breakouts in smart contracts. I guess there is no more time, that will be okay, so that as the fresh minds tomorrow is Thursday.
Tomorrow is Thursday, yes.
So that on Friday we can fresh minds to do React. I think with React we shall look at what is required. Most significant things like hooks, we shall see.
Okay, thank you so much for the guidance. Otherwise, I think this session can be stopped here. I will post I'm going to make corrections on this. There was something here that failed to work. Actually, yeah, I think maybe we could finish with this default binding. Is it okay, or we close? We close and start at this tomorrow.
Mr. Rudy, orange.
Maria has already showed me signs of decline that will continue. Okay, I think we can start from here tomorrow. Yeah, thank you very much. Have a wonderful night.